So let's do some practice problems with Beer's law. First, we're given with a bunch of data points, and this says it is measured absorbance and concentration. Now, this data includes the concentration in mm, which is micromolar, and absorbance. So what is the slope? Now, slope can be found using any two of these points. So let's choose 0.96 and 0.48. Now we do 0.96 minus 0.48. The change in y value divided by the change in x value, which is 100 minus 50. Now if we plug that into our calculator, we're going to get 0.0096. And yes, although you can use any 2 points, if you use 2 different points like this, you're going to get a slightly different answer. But the answer is going to be close enough that the difference is acceptable. So let's just stick with 0.0096. And now, second part of the question says you dissolve this much penny in a 50.0 milliliters of HNO3. After reacting, we're like, okay, so the solution is blue and 100 milliliters. You test a sample of the solution and found out they have absorbance of 0.12 absorbance at 635. Calculate the concentration. So the concentration can be calculated by ABS divided by slope. Now, fortunately, it told us the ABS, which is 0.12. So it's going to be 0.12 ABS divided by 0.0096 as our slope we just found over here. And now this is equal to 12.5, and our units are going to be micromolar, micromolar. Now next, calculate the number of moles of Cu2 plus in the 100 milliliter solution. So our moles, we can use our micromolar. We found 12.5 micromolar, and for every 1 molar, remember micro is 1,000th. So every 1 molar is going to have 10 to the third micromolar. That is going to give us 0.0125 molar. Now that is equal to X amount of moles divided by liters, which is 100 milliliters, aka 0.1 liters. And now that can give us an answer of 1.25 times 10 to negative third moles, using our molarity is equal to moles divided by liters formula. Now next, calculate the number of grams. We can use our number of moles, 1.25 times 10 to negative third number of moles. And then for every 1 mole of copper, copper is on the periodic table 63.55 grams. So we plug that into a calculator too, and we'll get an answer of 0.0794 grams. Finally, we need to calculate the percent present in the copper. So let's use number of grams, 0.0794 grams of copper. This is the total grams of penny, which is 2.5 grams, divided by 2.50 times 100. And we're going to get an answer around 3.2%. 3.2% of the penny is copper. Now that's the first question. Second question, what is the molar concentration of copper 2 sulfate? It has a measured absorbance of 2.17. The absorbance of a 0.1 molar solution is 0.96. Okay, so another part of the Beer's law is, you can think of it as this. A1 over C1 is equal to A2 divided by C2. Now A1 is the absorbance of trial 1, and A2 is absorbance of trial 2, whereas C1 and C2 is the concentration that matches each one. So this is another way to determine an unknown concentration using Beer's law, and this is the proportion that we're going to use. So in this question, we have absorbance as 2.17. So 2.17, let's use that as A1. Now over concentration, we're looking for the concentration. What is the molar concentration? So let's write concentration is equal to A2. Now what is our second absorbance? 0.96. 0.96 divided by what's the concentration that goes for 0.96? 0.1 molar. 0.1 molar. So we cross multiply this, and then we do 2.17 times 0.1 divided by 0.96 is going to give us the unknown number, and our concentration will be 0.226 approximately. So when it is measured at an absorbance of 2.17, the concentration of the solution will be 0.226. Thank you for watching.